Hello, you tens. It's me again. Um, so we are starting with hazards. Just revision, just going over plate boundaries, and then we will look at case studies. Um, what we're going to be looking at today is constructive, destructive, and collision plate boundaries. We won't look at conservative because those ones are the ones that slide past each other and you get earthquakes very easy. So very quickly, we're just going to quickly go through these today. So it'll be a shorter lesson than what you've been having. And then we will move on to the earthquake case study, so Nepal and then Christchurch, New Zealand, next lesson, and get those done. So, constructive plate boundaries are when the plates move apart. Okay, so as the plates move apart, you get a gap, and then magma fills up in that gap. Because obviously you've got a hole, you need something to fill that hole, which will be the magma. Okay, this is an example of a mid-ocean ridge, so the mid-Atlantic ridge, which runs through where Iceland is. Iceland lies on this plate boundary, so Iceland is actually growing in size due to the fact that plate boundaries are moving apart and then magma's rising up in. So can you please get a sketch of this down? It doesn't need to be 3D. It can just look like this one. Okay. Don't worry about these tasks. I just pulled this slide from another lesson because it had the diagram that I needed. So just draw this diagram out. Remember, you've got your convection currents as well. So you've got your warm magma rising up. Okay, reaches the crust, it then cools down slightly and sinks, and then that kind of circular action creates almost like how a tank or a conveyor belt at a supermarket, when you go to pay to check out, that kind of action, so it rolls the crust away. Okay, so draw this diagram out, label it, label what's going on, and we'll then move on. So what I want you to do is I want you to do silver here, or purple, not bronze. Again, I pulled this from another lesson. Using your notes, explain how volcanoes form at constructive plate boundaries. I want you to tell me how, using this, a volcano would form. Okay? Because obviously here, where you've got that gap, magma's going to erupt out and it's going to eventually form a lip or a ridge, and then that will then form your volcano. Okay, so have a go at this question here, silver or purple, so either a 4 or a 6 marker. Pause the screen, have a go at answering those, and then we will move on to destructive plate boundaries. Right, so this is a destructive plate boundary. These are the ones that I like most. I find these ones exciting and interesting. These are the ones with the lava that I like to look at. So all of the interesting, like, igneous rocks that I like to look at in my spare time, those are formed at these sorts of plate boundaries. So what we've got here is we have got both volcanoes and earthquakes forming at the same plate boundary. Okay. Now, these earthquakes, you can get earthquakes at constructive plate boundaries because obviously the plates are moving, but they're not as violent as some say on a destructive plate boundary, like, for example, Japan. Okay. Japanese earthquakes can be very, very bad because of this plate boundary. So you've got here your oceanic crust and your continental crust, okay? Your continental crust is thicker, okay? Thicker, but it's lighter, okay? It's like a sponge, essentially. It won't sink, okay? It'll float. This, however, is denser, okay? So it's heavier. So even though it's thinner, it's heavier. So it's going to sink, okay? So what happens is this oceanic crust gets, the word is called subducted, okay? So subducted. So it goes underneath the continental crust. Now here, because it isn't smooth, it gets stuck and friction builds up. This release in pressure, the release in friction, it's like if you were to rub your foot along a carpet with some thick socks on, you might get a bit stuck, and then when you push really hard, then your foot will go flying out from underneath you. Exactly the same. And that zone there is called the Benioff zone. You do not need to know that. That's just a little nugget of information if any of you fancy taking A-level geology when you are done. Okay. So what happens is this friction builds up, and then where that friction is released, boom, you have an earthquake. Okay. So those happen deep down. Okay. And then what happens is this oceanic crust starts to melt because it's about 2000 degrees. It's very, 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 very hot. And then what happens is that molten rock becomes magma underground, lava above ground, magma. And then because it is hot and it wants to rise up, because hot things rise, hot air, hot water, hot molten rock wants to rise up. What happens is that will then build up, you'll get some pressure, it'll find a crack in the crevice, and what will happen is you will get a volcanic eruption. Okay? So, what I want you to do is draw that diagram out. Okay, it's a bit clearer on this screen. Okay, so draw that diagram out. Don't worry about those questions because we've kind of just gone through those with me talking. And then what I want you to do is pause it here, draw it, and then move on to the next slide to fill out the missing bits. So you've got here number 1, number 2, number 3, number 4, and then number 5 at the top. Okay, so can you then please draw those out for me, or write them out for me once you have drawn your diagram? Okay. So we also have destructive plate boundaries where two plates are moving towards each other, but they're both continental. What's going to happen? That's right, I hear you. They're not going to sink, are they? No, because they're both too buoyant. So what happens is when they are pushed together, they crumple upwards rather than one buckling, giving way and being subducted. They both push up like so. And what you get is fold mountains. Okay, now some of these mountains can be absolutely ginormous. The Himalayas, for example. They are fold mountains where the Eurasian plate, Europe and Asia, were on one plate, and the Indian plate, which used to be down by Australia, over time that moved, that Indian plate. And what happened is at some point, I don't know, several million years ago, probably about 50 to 100 million years ago, they smashed into each other and caused uplift. Okay, so it would have been, we call mountain building events orogenies. A nice funny word for you. So it would have been an orogenesis where these mountains would have formed exactly the same as what happens in Scotland, because Scotland used to be separate from us as well, because we've got different rock types. So that would have happened again. Oh, that's ancient. But these, the Himalayas, would have formed in exactly the same way. So they will push together, fold upwards, and that is how they form. Okay, so can you please make a note of that, because we didn't really cover this last year. We focused mostly on conservative, constructive, and destructive. Now, these collision plate boundaries, you might get a question on fold mountains, you might not. It's best just to know how they form, but it's very unlikely you'll get one with this new exam spec. Okay, but still need to make a note of it. So, for the rest of this lesson, I want you to, with the use of a diagram, explain the formation of a volcano at a destructive plate boundary. Now, you might get that, or you might get explain the formation of an earthquake at a destructive plate boundary. Okay, so if you want to pick an earthquake, fine. If you want to pick a volcano, fine. Remember, you need to include different types of plates, how they are subducted, why they are subducted. Could you give an example of one? So a destructive plate boundary, you've got around the Pacific Ring of Fire. You've got like the Andes. Again, that's part of the Pacific Ring of Fire, but on the other side. Anything like that. Okay, so have a go at answering this question. As I said, it's a fairly light lesson this week, because the case study ones require you looking at videos and things, and that would just take up too much time. So you'll do that in your own time. So I will put the links up for that next week. Please keep sending me your work. I know some of you are in school, some of you won't be in school. So I expect that fewer of you will be looking at these, but if you can still send me some work in, especially if you're not going into school, if you're still staying at home like I am, then definitely send it in and I can mark it and send it back to you. So I will speak to you later. Have a lovely week and I will see you next week. Bye.